Hello friends, welcome to the world of C, the C programming. Programmer's model of a computer. We have computers everywhere. They simplify a lot of our tasks. They help in solving many problems. In various fields, health, education, entertainment, commerce, industrial growth, communication, defense, war, automobile engineering, you name it. A computer does not really solve a problem. It can only act as a facilitator. We have to tell the computer what to do and how to do it. We make use of the speed and precision with which the computer can execute the instructions that we give. It is important how you tell the computer to do what you want. The computer cannot think on its own. It does not understand our needs. We have to make it understand. There cannot be any ambiguity. Ambiguity. In real life communication among human beings, we can afford some ambiguity. We understand what is intended from the context. For instance, bank could mean a financial institution that helps in managing our money, or the edge of a river. When we talk about depositing money in a bank, we understand we are talking about the first one. There can also be structural ambiguity. He ate the cookies on the couch, for example, could mean that he ate those cookies which were on the couch as opposed to those that were on the table, or it could mean that he was sitting on the couch when he ate the cookies. What does this sentence mean? The bandage was wound around the wound. Need for special languages for computer. So we need a language that is precise and without any scope for ambiguity. It should also be understood by the computer, which means it should be clear what action the computer is supposed to take with each instruction that we give. We call such a language a computer language. Machine language. What a digital machine understands is highs and lows or on and off. These states can be represented in the form of ones and zeros in a computer machine. Machine's language uses sequences of zeros and ones only. A computer can recognize zeros and ones only. Every data that we give the computer is converted into sequences of zeros and ones to process on it. The computer machine communicates back to us in the same language. A program written in machine language would look like this: 1100 1100 110. Assembly languages. It is difficult to write a program in machine language. It is also not easily readable. Looking at a program written in machine language is vaguely comparable to looking at a DNA molecule atom by atom set D Hofstadter. Even a simple program uses a large number of zeros and ones, as we saw. To avoid this, people went for symbolic languages called assembly language. For each instruction, a short symbolic term or mnemonic was used. This is also a low level language, which means that it is not easily readable and it is closer to the machine than to human beings. For example, MOV EAX1, SHL EAX5, SUB EAX, ECX. High level languages. Then came high level languages. A high level language is closer to the human users than to the machine, in the sense that the machine level details are not visible in the language. There are no mentions about registers, for instance. They also hide the details of CPU operations like memory access. They are easily readable and easily portable across machines and platforms. They use many elements of natural languages, for example, terms like if, while and for. Fortran, Pascal, C, C++, they are all high level languages. A program written in a high level language is first translated to machine language and then executed by the machine. This process is called compilation. We compile a program and link it with some programs that are already available as part of the language to create an executable program which is in machine language. This is what we run or execute. Though there are several high level languages, the basic concepts in most of these languages are same. Hence, if one learns one language, it becomes easy to pick up other high level languages. History of C. C was developed in 1970s by Dennis Ritchie at AT&T Bell Telephone Laboratories. C is a combined development of two old languages, BCPL and B, which were also developed by the same lab. B was designed for computers in PDP-7 architecture, on which Unix operating system was originally implemented. B's inability to take advantage of some of the features of a new computer architecture called PDP-11 led to the development of C. Until 1978, it was used only in Bell Laboratories. In 1978, Brian Kernighan and Dennis Ritchie, the master brains behind the development of C, published the first edition of the C programming language. This description is commonly referred as K&R C. Following the publication of K&R C, computer programmers were impressed by the features of C and they started to use C to develop application and system programs. By 1980s, the popularity of C had risen high. Many compilers and interpreters were written for C and numerous commercial application software were also prepared in C language. The popularity of C led to the outcome of various versions of C. Many versions of C were implemented on a variety of mainframe computers, mini computers and microcomputers. The American National Standards Institute, in short ANSI, formed a committee in 1983 to set up a standard specification for C. In 1989, the standard was completed and was approved as ANSI X3.159-1989 programming language C. This version of the language is often referred to as ANSI C, Standard C or C89. In 1990, International Organization for Standardization ISO, a non-governmental organization for international standardization, adopted ANSI C standard. This version was called C90, but it is essentially same as C89. Most of the C programs written today are based on C89 or C90. Characteristics of C. C is a general purpose and structured language. It uses simple English keywords such as if, else, for, do, while, etc. C was designed originally as a language close to low level assembly language, so that compiling a program in C did not involve complex algorithms. It was easy to convert many available assembly language programs to C. C itself allows using it as a lower level language and also as a higher level language. This facility enables C to be used for both system programming and application programming. Despite its low level capabilities, the language was designed to encourage cross-platform programming. Thus, the language became available on a very wide range of platforms, from embedded microcontrollers to supercomputers. Another feature of C is that C uses a large number of operators and library functions that help users to write concise programs. Moreover, it enables users to write library functions of their own. As you all know, compilers or interpreters are also computer programs that translate high level languages into machine level languages. The compilers or interpreters of C are commonly available and are comparatively small in size. Due to a thin layer of abstraction and low overhead, C allows efficient implementation of algorithms and data structures, which is useful for programs that perform a lot of computation. Portability is another important characteristic of C when compared with other high level languages. Many of the computer dependent features are converted into library functions of C. Every version of C is accompanied by its own library functions. These library functions are moderately standardized and most of them are accessible by various versions of C. Therefore, C programs can be run on different computers with a little or no modification. Beginning with C. Now we can go deep into C. Learning C, like learning any high level computer language or a natural language, involves learning its alphabet and vocabulary first, and then learning the grammar, or syntax that defines how to construct phrases and sentences or expressions and statements as they are called in computer languages. Just like natural languages, we could construct complex statements from simple statements and expressions. Let us see the basic character set of C. This set includes numbers from 1 to 9 and English alphabets, both capital letters and small letters A, B, C, D, E, F up to Z, and special characters as seen in screen. Let us consider the structure of the C program. Every C program consists of one or more than one functions. Out of these, one function must be named as main. Each function must contain a function heading, that is a function name, and an optional number of arguments enclosed in parentheses, then a list of argument declarations if arguments are included in function, and a function body that consists of a compound statement. Each compound statement is enclosed within a pair of curly braces. That means that if once an opening brace is used, the compound statement should be properly closed with the closing braces. This is the body of a compound statement. A compound statement can contain elementary statements or expression statements as well as other compound statements. When a compound statement contains another compound statement, it is called a nested compound statement. In C, each elementary statement, also called an expression statement, should end with a semicolon. C programs can be typed in lowercase or uppercase, but using lowercase is a custom to type ordinary expressions. Also remember, uppercase and lowercase characters are not equal in C. Let us study the basic elements used in a C program. They are characters, identifiers and keywords, data types, constants, variables, and arrays, declarations, expressions and statements. We have seen the character set already. Identifiers are the names given to variables, functions and arrays. Identifiers consist of upper and lower case letters, digits and the underscore. Any combinations of these can be used as an identifier, with the restriction that the first character must not be a digit. For example, x, y, grand underscore total, underscore sum, z30, etc. are all valid identifiers, but 9th page, AC hyphen number, they are all invalid identifiers. C keywords. C makes use of a list of 32 keywords or reserved words that carry special meanings. Note that all keywords in C are written in lowercase. A keyword may not be used as a variable name. The following list contains standard keywords. Constants and variables. A constant is an entity that does not change, but a variable could change its value as the name suggests. A variable is an identifier that is used to store some data or value within a scope of the program. A variable reserves a certain amount of memory to store the data that corresponds to the value of the variable. There are mainly 4 types of constants: integer, real, character and string constants. Integer constants can be decimal integer constants. For example, 0 to 9, 39, 41, minus 29. 32,767 is the highest possible value for integer constants on most of the machines. Then there are octal integer constants. For example, 0 to 7, 045, 063. So, here we add 0 before the number and all other digits must be in the range 0 to 7. We cannot have 8 or 9. And then hexadecimal integer constants. For example, 0 to 9, A to F, 0x56, 0x3AB. Here we add 0x before the number and other digits are in the range 0 to 9 and A to F. Real constants or floating point constants could either be in fractional form. For example, 611.0 plus 712.8 minus 1563.56, or in exponential form. For example, 6.23 e plus 6, which means that 6.23 multiplied by 10 to the power 6, or 3.1 e31 or 2.3 e minus 4. A character constant is an alphabet, a single digit or a single special symbol enclosed within inverted commas. For example, B, hash or 3. A string constant is a combination of consecutive characters including none enclosed in double quotation marks. For example, India in double quotes, this is a C program in double quotes, or 32,042 in double quotes, or $100 in double quotes. Let us examine the following simple statement: int num. Here num is called a variable. This statement reserves a slot in the computer's memory with enough space to store an integer and stores some arbitrary integer value at that slot. Such a statement is called a declaration of a variable. Int is a keyword that tells the computer that this is an integer variable. See another statement: int num equal to 41. In addition to declaring the variable num, it also assigns the value 41, that is the decimal integer constant value of 41, which means 4 tens and a 1 to the variable. It means that the value 41 is stored in the memory location that is reserved for integer variable num. This is called an assignment statement, as it assigns a value to the variable num. Now, if one does num equal to 9, this statement overwrites the value stored at the location reserved, and the variable num now has value 9. One memory location reserved for an integer variable can hold only one integer value at a time. Variable names. A variable name is any combination other than the 32 keywords mentioned above of 1 to 31 alphabets, digits or underscores. A maximum of 50 characters suffice in most of the practical cases. Some compilers allow variable names whose length could be up to 247 characters. Some rules regarding the variable names. The first characters in the variable name must be an alphabet or an underscore. There should not be any commas or blanks within a variable name. No special symbol other than an underscore can be used in a variable name. Data types. C compiler makes it compulsory for the user to declare the type of any variable that the user wishes to use in the program. This is done along with the declaration of the variable. The basic data types are int, char, float and double. Int represents an integer and such variable can store integer values only. Char represents a single character. Float represents a floating point number or a real number, that is a number that could contain a decimal point or an exponent. Double represents a double precision floating point value. Basic data types can be qualified by using data type qualifiers like short, long, signed and unsigned. These qualifiers enable ordinary data type variables to store more or less data than they can store normally. Signed and unsigned can be used to determine the presence of positive or negative signs with the value. An integer variable can hold only an integer constant. A real or float variable can hold only a real constant, and a character variable can hold only a single character constant. Comments. The user may include text in a C program to make the reading easy and ask the compiler to ignore that text while compiling the program. Such text is called comments. Sometimes such remarks or comments will be useful to identify the program. Comments are placed within delimiters, that is /* and */. Anything that comes in between these delimiters will not be executed and will not affect the flow of the program. A comment that begins and ends in the same line could be marked with a // at the beginning. All text following this in that line is ignored by the compiler. For example, look at the screen. Here the comments are placed within the delimiters. Statements in C. The alphabets, numbers, special symbols, constants, variables and keywords, when properly combined, forms expressions and statements. A statement instructs the computer to perform some action. There are various kinds of statements in C. Some of them are declaration statements, assignment statements, output statements, input statements, control statements and loop statements. Declaration statements declare or assure the nature of the type of variable. A single declaration statement could be used to declare many variables provided they are all of the same type. For example, int a, b, c or float r1, r2. Assignment statements are used to assign a value to a variable using an assignment operator equal to. On the left side we have a variable, and on the right hand side we could have either a constant, another variable or an expression. For example, a equal to 5, b equal to a, b equal to a plus 5, c equal to a equal to b. Output statements generate the output of a program and use library functions like printf and fprintf. Input statements are used to read or input data. This is done with the help of functions like scanf. We will learn the syntax as we start writing our programs. Control statements are statements that dictate the sequence of execution of statements in the program. Unconditional control statements just transfer the flow to the desired point in the program. In conditional control statements, groups of statements are executed or skipped depending on whether an expression evaluates to true or false. Loops are groups of statements that get executed repeatedly as long as some condition holds. Compound statements consist of many individual statements enclosed within a pair of curly braces. For example, look at the screen. Here 4 statements are enclosed within 2 curly braces. Escape sequences. An escape sequence always starts with a backslash and is followed by a letter or by a combination of digits. An escape sequence is regarded as a single character and is therefore valid as a character constant. Escape sequences are typically used to specify actions such as carriage returns and tab movements on terminals and printers. They are also used to provide literal representations of non-printing characters and characters that usually have special meanings, such as the double quotation mark. For example, look at the screen. Backslash a represents a bell sound, backslash b stands for a backspace, backslash n stands for a new line. A slash 0 or null will be added automatically at the end of every string value. We will use this later. The program can be written in a file using any of your favorite editing programs. Emacs, VI, Vim, GVim and Notepad are some commonly used text editors. In the file, we write the following lines and name it test.c. So, here we have a comment, program to print welcome to C lectures, and then we write #include stdio.h, and then we have a function main, and we open the curly brace, we write printf in double quotes welcome to C lectures /n, and we close the curly braces. For basic read and write operations, that is scanf and printf functions in a C program, it is necessary that we write #include stdio.h at the beginning of the program. It tells the compiler to use the functions like printf and scanf that are declared in the file stdio.h, which comes with the standard C library. Main is an integral part of any C program. The main body of statements that get executed follows this line enclosed in 2 curly braces. Printf is a function that prints or shows at the terminal whatever it is asked to print. In this case, it writes welcome to C lectures, and then the cursor goes to the next line. /n is a special character that means a new line. Compiling and executing the program. Once the program has been typed, it needs to be converted to machine language with zeros and ones before the machine can execute it. To carry out this conversion, we need another program called a compiler. A command of the form gcc test.c compiles a program that is written in file test.c and generates the executable file with a default name a.out. If we want the executable in a different name, we could specify that when we compile. We may write gcc test.c -o test. it generates the executable file with the name test. Now, if we type a.out or test at the terminal, it executes the program and prints welcome to C lectures at the terminal. Scope of variables, global and local variables. A variable that can be accessed from anywhere within a program is called a global variable. The points from which one can access a variable is called the scope of the variable. A global variable has a global scope, which means that it can be accessed from anywhere in the program. In C, we can make a variable declaration global by declaring it outside all the functions, that is including main, if the entire program resides in a single file.